Hi, and welcome to 5.1, which is talking about nth roots and rational exponents. So today we're going to start just over something that's going to be kind of new. I mean, it's really kind of a built on of what we did first semester, but it's really a bunch of stuff that is going to be new to you. So it's okay if after this if you're still slightly confused, as a lot of this stuff just takes a lot of practice to remember what to do in what situations. So up until now, we have just seen square roots. And we've seen other exponents, like you've seen an exponent of x to the second, x to the third, x to the fourth, and stuff like that. But what we haven't seen is x to some exponent that's a fraction. So up till now we've seen let me change colors here. We've seen square roots. And square roots can get rid of squares and stuff like that. But what you might not understand is that there is actually a number right here. When you're doing a root, there's actually a number right there. Now, it's not there because it is understood that if you have a square root, that there is a 2 there. Similarly, like if we have x to the 1, you don't put the 1. X to the 1 is just x, so we just leave the 1 out. Here, with a square root, we just assume that it's a 2, so we just don't put it. And so that's the same, as just a square root. But there are other roots. So there are roots where you're going to have other numbers here, like a 3 or a 4 or a 5. And so how do we deal with those? And how do they relate to exponents that are fractions? So instead of x to the second, maybe you have x to the 2/3 or x to the 3/4. So how do those relate to radicals? Because we know that exponents and radicals are linked in that you can interchange between them. If I have x squared and I needed to get rid of the squared, I could square root. So there are links between radicals and exponents. And so how do we deal with that? And that's what we're going to be doing today. Up until today, we've dealt with just even integer radicals. So, for example, we have just seen the square root or a radical with a 2 in it. But they could be any even number in there. So you could have a 4th root, you could have a 6th root, and so on. You can have any of those as long as they're even. They're going to follow these rules. So just like with square roots, you cannot have a negative number. So anytime when the number that's in, we'll put an a in here because that's what that's referring to, is the a is what's inside the radical. You cannot, if this number is negative, you cannot do it. Just like with square roots, when you have negatives, there would be no real solution or no real root. And so you could deal with I, and I only works with square roots. So whenever you have a negative in here, we just simply put that there is no real roots. You don't have to put nth. You can just say there's no real roots if there's a negative. And that's something we already know. You can't have negative in a radical. And so that's the same thing here. When it's even, you can't have negative in a radical. It's just no real roots. The other thing that we should already know about radicals, and this goes for any radical that is an even, has an even root, even nth root, is that if it's positive, we know we're going to have this plus or minus. So for example, when we did the square root of 4 or something like that, we would say that that's plus or minus 2, right? So that's something we also have to remember. So with an even integer, with an even root, you cannot have negatives. And when you do roots, when you're solving equations, you're going to get a plus and a minus. You're going to get those two solutions. That is the exact opposite than with odd integers. This is something new. We have not had odd integers in roots. So what I'm talking about is a 3rd root or a 5th root or a 7th root and so on. When you have odd, okay, odd roots, the exact opposite happens. So instead of, when you have a negative over here, when you have a negative, there's just no roots. When you have odd roots, you can solve a negative root. So if it is negative, you can get an answer. There are real answers when you do negatives in odd roots. And over here, just like when you had a positive number, you got that plus or minus. Well, when you have odd roots, there's only one real answer. So if you know the even integer rules, then you should know the odd integer rules because they're literally exactly the opposite. In an even integer, you can't have negatives. And when you get an answer, there's a plus or minus. In odd integer roots, you can have a negative and get a solution, and your answer will only have one solution. So that's what we have to remember here. I'm going to address this whole rational exponents here a little bit further down, so we'll skip that. Now, let's look at some practice with this. So what this is saying is that my nth root is 3, and what's in the radical is going to be negative 125. So this is a third root of negative 125. Now, because it's an odd root, I can have a negative and I can solve this. So you can put this in your calculator, or you can figure it out in your head. But basically, it's what times what times what. Since we're dealing with third roots here, is going to be 125, and that answer is negative 5. And if you want to know how you can do this in the calculator, you just talk to me. I showed it in class, but it's a little bit more tedious kind of to do this within the video. But if you want to know how you can do this in your calculator, then I can show you when you're in class next time. And that's negative 5. And that's because negative 5 times negative 5 times negative 5 is negative 125. And that's how we get that. Here, the nth root is 2. Now, because it's a square root, you don't necessarily need the 2 there, but you certainly can put it there. Negative 400. Now, this is where you have to recognize that this is an even root. So I can't have a negative in the radical. And so therefore, this is just no real roots. And then as far as number 3 goes, here, then this is the nth root of 6. So I have a 6 root of 64. This is, again, this one might be a little bit more difficult to try to figure out in your head. But, it's what to the 6th power is 64. What times what times what times what times what times what is 64. And the correct answer here is 2. Now, you might be asking yourself, well, isn't it supposed, this is an even root, right? Isn't this supposed to be plus or minus 2? If you are solving, like x equals like an equation, then yes. If you're solving and need an actual real value for a variable, then yes, you would need to do plus or minus. But if we're just saying what is the 6th root of 64, then you can just say 2. And actually, this is what the preferred way to write it is, just 2 and not plus or minus, because you're not actually solving for anything. You'll see that down below when we actually solve some of these. So that's what it is, because 2 to the 6th power is 64. Now, what about this whole fraction thing? So with fractions, there is a way to convert these into radicals that you can actually solve. This is something else that you can also check with your calculator. You can do this, in your calculator, and you can plug it in that way. And again, this is another thing I have to show you. If you need help and you want to see how you do it in the calculator, just let me know. But I'm not going to do it in this video. What we're going to do is we're going to convert this to a radical. And so you will need to show this work when you're answering these questions. You can't just put it in your calculator and get an answer. We need to convert this first to a radical. And so how do we do that? Well, when you have a rational, what ends up happening is this denominator goes outside. And by outside, I mean, here's the radical, or the root, that whatever is in the denominator will come outside. And whatever is in the numerator and the number will stay on the inside. Now, this is 64 to the 1 power, to the first power, so you don't really need that 1 there, I should say. And so, but now we know, you might not know this, 64 to the 1/2 power, but you certainly know the square root of 64, and that is 8. So switching it to radical form and then evaluating is something you're going to have to do. So I'm going to do this one as well. This one is a little tricky, and I'll show you why here, but same rules apply. You have a 5 in the denominator. That's going to come out. So my root is going to have a 5 there, a fifth root, and then I have negative 32 to the third. Now here's the problem with this. We cannot have exponents inside of radicals. We would have to change this. You could do negative 32 to the third power, but that's a big number. And if you're trying to do this without the use of a calculator, you might have a hard time with this. So there's another way to rearrange this. And this is something you're going to have to know how to do anyways. So this is why we're doing it, because in the next section here, you're going to have to be able to do this. So I'm going to require that you make this change that we're about to do. It might seem pointless right now, but you'll see its worth when we do this in later lessons. What we have to do with this fraction is we have to change this. We have to change this 3/5 by saying, well, 3/5 is just 1/5. And it's bothering me that this is too big. This is really just 1/5 times 3. And I hope you all would agree that 3/5 is just 1/5 times 3. 1/5 and 1/5 and 1/5 would be 3/5. So what we can do by separating it, that it's 1/5 times 3, is just change this part to a radical, the 1/5. And we'll deal with that 3 later. But now with the 1/5 there, I can say, okay, well, the 5 is a denominator, so it's going to come out, and then negative 32 to the 1. Well, and since I don't need the 1 there, I do need the radical though. I can get rid of it, and now I can figure out the fifth root of negative 32. That's a little bit easier than trying to do 32 to the third power. And so the fifth root of negative 32 is going to be negative 2. And now I can bring that 3 exponent down and attach it to my answer. And then we can do negative 2 to the third. Negative 2 times negative 2 times negative 2 is negative 8. And that makes it much easier to solve when you're doing this by hand if you don't remember how to do it in a calculator. And you're going to have to show this work in the process. And you'll understand why in later lessons. But right now, just understand that that's the work I need to see when you're doing these. So here's another one. And so we have 7/5. And so we could just change this saying that it's 1/5 times 7. And so I can just do this part, 32 to the 1/5, which is the denominator is 5. So the 5 will come out here. And I have 32 to the 1, or just 32. And I just did 32, or the fifth root of 32. I did negative 32, so it was negative 2. So this is just 2. But then I can bring the 7 down and just do 2 to the 7th, which is 128. And then again, that's much easier to do than trying to figure out 32 to the 7/5. Last one here, 81 to the 3/4. Again, we can say that 3/4 is just the same as 1/4 times 3. And so we can do 81 to the 1/4. That 4 denominator means I have a 4th root. And then of 81 to the 1st, or just 81. The 4th root of 81, this is something, again, you're going to get used to, some of these roots are going to be pretty obvious, but that is 3. And then I can just go down here and, and bring that exponent down. And 3 to the third is 20. Oh, that's not going to be a 7. 27. This next section here is going backwards. So this one was going from rational exponents into radicals. Now we're going to go from radicals to rationals. So how do we go from roots into rational exponents? And so we have to remember our rules. In this first one, we have to recognize that the radical, since there's nothing there, we assume that to be 2. And then remember, what that root, that nth root, is actually your denominator. So this will come here as the denominator, a little fraction there. And so what this will just be is a to the 3 over 2. And so we can just match that. This one, anytime there's a number, which there's a number on the outside, we kind of ignore it. So we're going to just ignore that number right now. We're just going to focus on this. So there's not another number, right here where the a is. There's not another number here, so we just assume that to be 1. And so again, this can come out and become the denominator. So I get a to the 3 is the denominator, and then the 1 is the numerator. Then that negative that's out there just gets attached there at the end. And so that goes here. Here, again, what's in the radical will go in as the numerator. So it's going to be a to the 2/3, which is right there. And this one's interesting. This one requires you to know your exponent rules. So anytime you have an exponent, and first of all, let's change this to an exponent form. We assume that to be 1, so this is going to go down as the denominator. So what this looks like is 1 over a to the 1/3. Now, the problem is we can't have exponents in the denominator. This is a rule back in Algebra 1 that you guys talked about. You can't have exponents in the denominator, so what we need to do is move them to the numerator. I shouldn't say you can't have exponents in the denominator. You can, but those usually are accompanied with variables here. And so we need to move this up. And so the way to move this up is to change the exponent's sign. When you move it across the fraction sign, then it changes signs. And so we have a to the negative 1/3. And that's why that is that. So that's going from radicals to rationals. And the last piece here, we're just going to do 16, 17, 18. This is, if you were here for the warm-up, we did some problems like this, but this is now solving equations. So this is very similar to what we did first semester when you were solving equations, except we had x squareds, and so you just solved them. But so the same thing goes here. So we're going to solve, and we're going to get x by itself, and so I need to divide both sides by 6. Now what makes this different, obviously, is that we have an exponent of 3 instead of an x squared. But you have to remember, so the same rules apply here. When we had a squared, to get rid of a squared, we use a square root. Well, the same thing can happen here. When we have x to the 3rd, we can get rid of it by using a 3rd root. And so we're going to do a 3rd root of both of these. That will cancel, giving me x equals. Now remember, this is an odd root, so I will only have one answer, and the 3rd root of -1 is -1. By the way, FYI, anytime you're dealing with a negative in the radical and you can have a solution because this is an odd root, your answer will always be negative. Anytime there's a negative in the root, then you're always going to get a negative answer if you can get an answer. I'm just going to move down first, and then I'll move over. This one, same thing. We're going to solve. So I'm going to add 32, add 32. So x to the 5th equals -32. Again, to counteract a 5 as an exponent, we can do a 5th root. So that will cancel out, giving me x equals. Again, I'm only going to get one answer because it's an odd root, and the 5th root of -32 is -2. Okay. Here, same process. I need to get x by itself, so I'm going to start by dividing by 2 both sides. So I get x plus 5 to the 4th equals 64. At this point, I can't move this 5 over, so I do have to remove the exponent. A 4, an exponent of 4 can be canceled out by a root of 4. And that will cancel out, giving me x plus 5. Now this is not a nice number. The 4th root of 64, I believe, is 2.83. One other thing we have to remember, though, is that we have an even root, so this will have a plus or minus that's accompanied with it since we're solving. Then when we subtract the 5 over, we have to remember that we are doing this. We're going to have two different answers. You have to do positive 2.83 minus 5, and then you have to do negative 2.83 minus 5. Now, positive 2.83 minus 5 is going to be negative 2.17, and then negative 2.83 minus 5 is negative 7.83. And so those are your two answers. And that is it. That's all the problems.